Hello, my name is Tom Coolidge. I'm Esri's Director of Pipeline Industry Solutions. I am facilitating today's webinar along with my colleagues, Jeff Allen and Sam Cook. Jeff is Esri's Global Pipeline Practice Lead. Sam is a Solution Engineer in our Natural Resources practice. On behalf of us all, welcome to our focus on merging location and artificial intelligence. We think you'll find our time together today to be interesting, informative, and helpful. Before we get started, please take a moment to note the webinar control panel on your screen. I would like to encourage you to post your questions as they occur to you during the presentation in the GoToWebinar Questions dialog box. We will answer as many general questions that can be answered concisely as time permits after the webinar. Questions requiring longer answers and some technical questions that are better answered by one of our specialist colleagues will be handled individually after today's webinar. And if we can't answer all general questions during today's allocated time, we'll answer them in a FAQ document that we'll distribute afterwards to all attendees. Please also note you can switch between telephone and computer speaker audio and adjust your view to full or partial screen. And again, please note today's webinar is being recorded. For our safety moment today, we want to focus on mapping the way to a healthy future. With so many of us around the phone being GIS professionals, this is GIS speak for something I suspect we're all hearing daily and talking about among our family and friends. You'll see the 4 GIS skills we encourage all of us to practice at all times highlighted above the boxes. And the 4 skills we're encouraging all of us daily to adhere to are understanding where things are. Right now, for us, that's staying at home when possible for most all of us, and keeping an eye out for neighbors who could use your help. If you do go out, remember to measure distances, keep at least 6 feet from others, and by all means, count objects within your polygon. Stay away from gatherings of more than 10 people. And while we have the skill with ArcGIS to determine geometric coincidence for now, avoid touching other features, and if you do, wash your hands promptly. Let's all stay safe and stay well. And now, please welcome my colleague, Jeff Allen. Jeff?
Excellent. Thank you, Tom. Thanks, everybody, for joining us this morning from your home offices or wherever you find yourself today. Keep safe. So today we want to kind of focus on some newer technologies from Esri. A lot of the discussions that we've been having as an industry and a lot of my presentations of late have been around kind of that modernization of the enterprise GIS. A number of organizations are looking to build out their digital twin and increase the fidelity of the data that sits inside of their enterprise geodatabase. So with that in mind today, we want to look at ways that we can leverage that investment in that modernized GIS and that higher fidelity data and actually do something analytically with that data using some of the back-end tools that we're going to show you today. So I often come back to this common operating patterns within your organization, right? This is really, for me, the key to understanding the entire Esri stack. So when I talk about modernization of the GIS and the digital twin, clearly all those workflows and a lot of that investment happens under the data management pattern. But today, really what I'm going to do is shift our focus downstream a little bit into that analytics, right? I kind of think of this as the verb to the noun of the data management, right? I have what I have in my data management system. What operations can I act on that data to actually come up with predictive trends and really answers for my organization that help us with our business. So that's the pattern that we're going to fall into today as we explore the rest of the webinar. But as we start talking about these newer technologies, we can't really avoid the current conditions today. Not only do we have the global pandemic that is impacting consumption of raw materials and affecting our industry, but the downturn in crude prices as well is something that we read daily, if not hourly. So as we start talking about some of these new technologies, we also have to look at the bottom line, right? How do we pay for this stuff? How do we bring value to the organization? And it's not all bad news either, right? So if yesterday the news was bleak, it seems like you can open up your browser today and see some hope on all fronts. So we need to really kind of look for a way to ride the wave. What can we do on the top and what can we do on the bottom of these curves to help our organizations? So I really wanted to spend some time in the front end of the presentation, really talking about how do we justify the cost? How do we justify the investment in this GIS technology? It's a question that's often put to me, and oftentimes it's very hard to quantify. But we've been working with that question quite a bit at Esri and have come up with some guideposts here and some examples that I want to share with you about how we can justify some of this technology and these processes, both in good times and bad, as we move through this transition period. And so we think about the cost of the GIS or what the benefit of the GIS is. It really comes down to what that expected return on investment. And so we have here just a basic formula that calculates ROI for these types of processes. And it basically takes savings, whether that be top line revenue savings, bottom line expense savings, or risk mitigation, cost avoidance, and then divides them by the total investment in the GIS. And when we do that math, we're typically looking for an ROI of 15% or greater, right? If I was to take my money and put it in the stock market or put it in the bank and get 15%, I'd be a happy camper. So when we talk to management, we talk to the C-level suite within an organization. If we can justify what we're doing and show that we're bringing an ROI of 15% or greater to the organization, you're certainly going to get a lot of attention around these projects. So I want to start with a couple of actual real-world examples of what this ROI looks like. So this is a small water utility in Alabama. And so they were using our enterprise platform because they predicted, or they had a theory that they had a number of meters out there that weren't accurately recording the amount of flow or in turn the amount of revenue captured for this organization. So using some GIS analytical workflows, they identified over 3,000 meters that were not recording the flow properly. And if we convert that to a revenue stream, they predicted that that was a loss of revenue of about $300,000 a year, which if those meters were operating correctly, they would actually be able to return. So again, this is an ROI example of the top line savings. We're actually putting revenue back on the books. So it took them about a week to run this analysis. So they had a sort of an operating cost there for their GIS analysis to do this. And in this example, we didn't calculate any risk factors into this, but if we want to back calculate or solve for GIS investment, they could have invested about $257,000 in the bottom line there of the GIS investment, which would have, if we did that math, would have given them an ROI of 15%. In this particular case, they had a small utility enterprise agreement from Esri. So their investment in their GIS to do this workflow is only $25,000. So their actual ROI on this one project alone was 1,200%. So pretty good a return on investment. And I think if any of us were to show that type of ROI to any kind of our executives, projects like this would pretty much be a no-brainer for any type of organization out there. So let's take a look at what potential bottom line savings would look like. So here's another example. This is FedEx, and FedEx operates about 240,000 flights a year, about 650 flights per day. And they use the power of the platform to help schedule their maintenance and planning application, which makes sure they get the right parts in the right location when the planes need them. And so for their example, they are calculating that if they can if they can save 2% or reduce their delay in flight just 2%, which is 2 flights a day out of that 650. And if they can assume that only 60% of that is actually accurate, then the value proposition of their GIS is about 13 million on the bottom line. And of course, they are nowhere near that from a GIS investment. Now, looking at the solution in 2018, only 60 flights were delayed. So if you do that back math, 60 flights delayed for the entire year, they have quite a bit of ROI on this one project alone within their organization, just on the bottom line savings. And then our last example is this for risk mitigation, was a city council district in Ireland. And what they were doing is they had a huge project to go out and replace road signs. And one of their concerns was overhead and underground utilities. As they were digging and putting foundations in for these signs, they wanted to make sure that they didn't have any obstructions and didn't hit any utilities along the way, right? So they did a bunch of research and sort of back office work for all these locations instead of having to go to the field. And they also felt that if they could avoid a single incident would cost them about $10,000, and they had about a 1% probability of that happening. If they could do that, they would then have a GIS investment of greater than 456,000, plus the safety personnel aspect of this. And this actually investment was only about a week's worth of work in the office. So very much higher than that 15% mark. So the reason I wanted to give you these examples is I wanted you to really think of these and have these thoughts in the back of your mind as we look at how we're going to leverage some of this location intelligence and the GOI framework that I'm going to show you next. Because in each of these upcoming examples, we're going to see examples of where we can increase revenue, where we can decrease operational costs, and where we can reduce risk, which is really going to have an increased ROI for your GIS and your company, right? And that's really how this is all going to blend. Any of us are looking at implementing new technologies these days or coming up with new workflows. We're really going to have to think long and hard about how we justify these projects internally based on their current operating conditions. And so this is the key to the puzzle, to be able to show what we can do with decreased staff, we can increase revenue, we can reduce risk across the organization using some technologies. And I guarantee you, if you put some of those ROI numbers up on the blackboard within your organization, you'll get some increased interest in what you're doing within your GIS organizations. So with that, I'll hand it over to the fun part. Sam's going to take you through some of the baseline information models and things we have for artificial intelligence and location intelligence, and then show you some real world demos. And with that, I'll turn it over to Sam.
Thanks, Jeff. So now that Jeff has kind of gone through and set us up in terms of the value of these kinds of projects, I'm going to dive in and talk about the technical aspects. We're going to see kind of the process associated with the platform, what kind of capabilities you have access to, and then some examples of how you might use this in a real world project. So the first thing I like to start off with is showing everyone that ArcGIS is a powerful and comprehensive platform for spatial data science. And what I mean by spatial data science is analytics that tend to use machine learning, AI, or other advanced techniques to manipulate your data in such a way that you can automate very complex tasks. So these buckets that you see here generally describe some of those components that make up the data science process. And it starts with kind of data engineering, manipulating your data so that machine learning models can consume it, or so that it doesn't have a whole lot of missing data, or so that it's clean, essentially. And spatial analysis and machine learning are kind of one and the same, really. Machine learning can perform a spatial analytic function, and a subset of spatial analysis includes machine learning. But really the important component there is that you're performing an analytical task that doesn't nearly kind of interact with data that is spatial. It takes that spatial component explicitly into account, either at the algorithmic level or at a feature engineering level. And we'll cover feature engineering here in a little bit. And then you have these other buckets, the two of which that I want to cover very explicitly are visualization exploration and sharing and collaboration. These two also go hand in hand because when you kind of visualize your data, you want other people to see that visualization, and sharing and collaboration is kind of the hopeful endpoint for all of your machine learning and advanced analytics. You want people to see the work that you've done and be able to make decisions based on it. And then big data analytics. Big data analytics is an underlying component of all of these, right? So at any point you can be working with big data. The same for modeling and scripting. At any point you could be creating models or writing scripts. For big data though, what we mean is something very specific. It means that the size of your data can't fit within a standard database management system. It needs to have something like a spatiotemporal big data store or some other specific distributed file system. And that's what we consider to be big data. And then modeling and scripting is, automating your GIS. And this whole process always begins with your data, data management, data engineering, data exploration, and ArcGIS integrates all the different types of data that you typically work with inside of a geospatial, intelligence and analytics platform. A few of these that are important to mention that we commonly work with are tabular, unstructured, vector, and imagery. And this is where kind of a lot of our focus is, but we also have the capability to perform real-time analytics on feeds with thousands or millions of events per second, LiDAR, where you have billions of points in a point cloud, and you want to extract features from a lot of the noise. CAD and BIM if you're into any kind of engineering processes that you need to analyze or integrate, and then full motion video and multidimensional, where you've got a lot of layers that kind of need to be processed, and it's very, very heavy data that you need to be able to work through. And same goes for 3D. And all of this can be manipulated and analyzed out of ArcGIS. And the way that we achieve that is by integrating open science tools and experiences with the platform so that you can perform analytics using the tools that are familiar to you, but integrate with your geographic information system. There are two tools that are key to us doing that on the Esri side, the Python API and Python notebooks, which is kind of an interactive experience where you can write Python alongside your favorite Python libraries, pandas, matplotlib, scikit-learn, etc. And our Python notebooks kind of wrap the Jupyter kernel, but give it a tighter integration with the ArcGIS platform. And you'll see that integration later. Now, ArcGIS can analyze data in the context of location and time in a number of different ways. We've already talked about AI, machine learning, deep learning, but I want to clarify what those terms actually mean. So artificial intelligence is kind of the big bucket of kind of when machines learn how to do a thing. Machine learning is a subset of AI that uses statistical analysis to allow a machine to become continually better at a process that involves a lot of numbers or data. And we'll get into that a little bit more later. And then deep learning is another subset of machine learning that involves a neural network with a hidden layer. That doesn't mean a whole lot of anything except for that there's some parts of the algorithm that you don't see, but it's essentially machine learning with that one hidden layer. And then you have raster analysis, which is the same thing, but applied to raster data sets, big vector and tabular data analysis, real-time analysis, which involves streaming those live feeds, your standard analysis, and then network and routing. Network and routing is probably particularly important for people in the pipeline industry, as a lot of your pipeline data sets can sometimes be composed of networks or utility networks or reference pipelines. And this functionality is always getting better. So we've added new capabilities for spatial statistics that take into account explicit, spatial relationships between your data. So for example, density-based clustering under the hood, that's kind of doing clustering based on where things are located. We've added new charting capabilities so that you can visualize your data in new and exciting ways to grab people's attention or make more explanatory visualizations. We improve our raster functions all of the time so that you can apply custom analysis to subsets of rasters. And then we're adding improved processing capabilities. So we've returned the ability to create models inside of ArcGIS Pro at 2.5. We've added Python notebooks in ArcGIS Pro at 2.5. and we're making more scalable capabilities in geoanalytics and raster analytics to perform deep learning tasks. And those deep learning tasks generally fall into one of several buckets. There's clustering, classification, and prediction. And clustering refers to identifying something that is, a statistically significant cluster relevant to its neighbors. So you might say this pipeline, section of pipeline needs significantly more maintenance than the sections of pipeline around it. Or prediction, I want to predict how much it's going to cost to maintain this pipeline in this area based on some environmental or metadata about the pipe, those kinds of factors. And then classification. So you might want to classify a surface, say, is this vegetation? Is this impervious surfaces like concrete or steel? Are these buildings, trees, etc.? So those are some examples of kind of those three different buckets. And we'll see in the demonstration how each of these buckets kind of impact what you're doing. And a key tool for us to actually perform those in those three different buckets is ArcGIS notebooks. And we've made it to where you can experience this kind of spatial data science platform your way. So we now have notebooks in Pro at the workstation level. We have ArcGIS Notebook Server at the enterprise level. And then we are also coming out with the software as a service version that you can have access to in the cloud that's managed for you, where you'll be able to access ArcPy, your traditional desktop geoprocessing tools, and the Arc API for Python. And these give you access to all those same powerful capabilities for spatial analytics, data engineering, automation of your GIS inside the ArcGIS API for Python across a range of different environments. A key component for deep learning of the ArcGIS API for Python is ArcGIS.learn. It's our submodule that allows you to perform artificial intelligence and machine learning across the entire pipeline. So data preparation, model training, model management, and model inference are kind of the steps that you go through. So you can prep your data, you can actually perform training so that your model learns what it needs to do. You can manage your models, like saving your progress or having different versions of your models. And then you can perform inference, which is actually when the model takes the act that it's supposed to do, whether that's detecting objects or classifying pixels. And you can do this with all of your different types of data, LiDAR, full motion video, unstructured. And when we put this kind of GeoAI into action, we get some really interesting and really valuable use cases. For example, classifying land cover. Let's say that you have laid down a pipeline and you buried it and you want to monitor land cover classification to see if there's any vegetation growth on your right of way. You can do that with pixel level classification. Or feature extraction. You might want to extract some building footprints so that you can keep track of what's encroaching on your right of way. That would be either classification or feature extraction in some form or fashion. And then maybe predicting where markets are going to move based on well pads are kind of being constructed. And we'll take a look at those examples in our demonstration. For now, I want to review a case study before we get into the demo that actually kind of describes the process that you go through inside the ArcGIS platform to make deep learning a valuable workflow. So you start with the requirement set. So for example, you've got a bunch of GPS data, but you don't have a road network, and you want to provide the ability for your field workers to travel directly to their assets. You want to understand what kind of roads you have available for optimizing routes or managing routes. And then you want to also avoid a lengthy manual digitizing process. Maybe there's thousands of miles of road and you don't want to manually kind of click through and draw the polylines and make a network data set yourself. This is some of the common use workflow that we've seen across the natural resources sector. Kind of goes like this. You collect those GPS breadcrumbs from your field workers, often using Tracker for ArcGIS, which is one of our mobile applications for collecting GPS data. You then train a model to extract road features from GPS crumbs. And you can do this in ArcGIS Pro or ArcGIS Notebooks, leveraging one of our server capabilities like geoanalytics. And then you can output a road network dataset as a mobile map package from ArcGIS Pro that field workers can then download and navigate on roads with using Navigator for ArcGIS. So this entire workflow ends up resulting in models that look something like this. And the points themselves will actually adjust to a Euclidean distance. So point A to point B, it'll take that and bend the road to where it matches GPS data sets to a road feature that then becomes an actual navigable road network. So key things we've learned so far before we jumped into the practical stuff. The ArcGIS platform supports spatial data science across its entire workflow in whatever environment you're comfortable in. We can integrate data into the ecosystem for the entire process of data engineering, analytics, visualization, and sharing, and you can experience it your way, either in a desktop, cloud, or server, whatever makes sense for you. And then the key components at a software level are image and raster analytics server if you're dealing with imagery, spatial analyst or image analyst if you're at the desktop level, and then ArcGIS.learn plus the rest of the ArcGIS API for Python and ArcPy. And finally, geospatial AI workflows in ArcGIS generally fall into those buckets: clustering, classification, or prediction. Now let's go ahead and jump into the demonstration. We'll start in ArcGIS Pro. What you're looking at here is the Delaware Basin. Now I've got a particular problem with the Delaware Basin. It's a booming space of activity, but tracking and keeping up with it is a very hefty process. Manually digitizing all of the well pads isn't an option. Publicly available records aren't as complete as they should be, and proprietary data purchases sometimes get expensive, and it's harder to keep up with them. All right, so across this landscape, you can clearly see dozens of well pads, you can see frac ponds and roads, and this means that medium resolution imagery is probably sufficient for us to be able to identify and track these objects in the Delaware Basin. And what we're really interested in is this kind of change over time. It would be pretty lengthy for us to do this manually all the time, but if you kind of swipe down and take a look at where there's data that changes from year to year, so from month to month. For example, you see inside these yellow boxes, you have well pads that exist, a couple of months later that didn't exist before. But I can't just stack this imagery and repeatedly do for a larger area. So, across the entire Delaware Basin, this is just not something that's feasible. What we eventually want to get to is pretty straightforward. I want to be able to start with my baseline of well pads that I know are there. From this data in particular was provided by Drilling Info, and then I want to detect these well pads kind of as they emerge. And you can see this time progression that shows how the well pads develop inside the Delaware alongside the frac ponds, which are demarcated in red. Now to kick off this process, we start with the training data set. And the training essentially is just us marking the objects that we want our model to be able to detect. So in this case, I've marked out in blue well pads that need to be detected, ponds in red, and then active well pads in green, meaning that we have some indicator that there's active behavior that's happening on those well pads to help us track activity. Once I've gotten to this set, I want to export this data into a training data set. I'm a notebooks person, so I can either do this using ArcGIS notebooks for Pro, or I can use it in the web browser. Here in ArcGIS Pro, kind of the workflow that we go through. We get access to that training data set of well pads. We then bring in the Sentinel-2 imagery, and we apply a raster function to the Sentinel data, which essentially allows it to display a natural color. We then export the training data for deep learning, meaning that it'll chip up all that imagery into small bits where we can perform detection. We prepare the data, and this will show us a batch of kind of data that we're working with, these chips of Sentinel data. We train our model based on this parameter called the learning rate. And then we show the results. So here's our ground truth and here's our prediction. This actually shows that the model is doing a little bit better at predicting well pads than our human counterparts that did the training data sets. You'll have that across multiple sets of chips. Now that I'm done actually training the model, I can save it so that I can reuse it, and then I can actually deploy it as a deep learning package to a portal for ArcGIS, and then detect objects. So with a single call, I use that deep learning package to a model, and then perform detected objects across whatever imagery it is that you want to pass it into for your particular area. Now, if I don't want to do this inside of ArcGIS Pro, I can also do this inside of the web browser in ArcGIS Notebooks. Here, I have direct access to files that I've uploaded to ArcGIS portal. I can add data that exists from inside my content. So I get a very familiar interface. It's the same set of instructions and process no matter where you are. Now that I've got the model and I've performed inference, I need to be able to take action based on that model. So we can end up with a dashboard that's something like this, that in real time, as you kind of pan across based on this image service that exists under it, will perform some function. In this case, it's just going to show us how many active well pads there are for a particular area, how many frac ponds, how many well pads that are just generally detected. And then I can see new detections by month, indicating that, 19, we had slower growth of well pads in certain subsections of the month. And then as you select data, it'll kind of highlight which areas you're looking at. Another example of how we might use imagery involves pipeline encroachment. So we just discussed this, but I want to make sure that when people are building things near my pipeline and they're encroaching on the right of way, that I understand that. Excavation damage can cause significant failures and be a very costly thing. So if I can keep track of construction, I can also set up a workflow where people can go out and verify that the buildings that are being constructed aren't a risk or a hazard for my pipeline. However, medium grade imagery probably isn't going to do the job here. So as I zoom in, the imagery that you're looking at here is SkySat imagery provided by Planet Labs. And Planet has this imagery that's about 80 centimeters in resolution. If I skip back to that 10-meter resolution imagery, you'll note that this is basically just a collection of dots, and I wouldn't actually be able to tell. So when determining what kind of imagery you need, it is entirely dependent on your use case. To detect these small structures being built near my pipeline center line, I'll need something a little bit with higher resolution. Basically the same. You would, collect from the imagery a series of training dataset samples, which you can see highlighted here in green. Those highlighted in green get chipped out based on the imagery that you provided into those same little image chips we saw earlier. You then train a model to detect those buildings. Then you can specify a buffer. So meters, I'm only interested in the buildings that are being built within 200 meters of the pipeline, and I want to only understand what are the new constructions, since those are the ones I'll monitor. Once I'm there, I have the basis for an entire workflow that is based on this automated process. So instead of just letting it sit there on a dashboard, I can actually push out the things that we detect to Workforce for ArcGIS, which can then assign someone to go out into the field to review that construction and make sure that it isn't causing any damage. From there, I can keep an operations dashboard to show me where it is that I'm actually getting those workers to, how many of those buildings we've run through and made sure that they aren't causing an issue, and get that feedback, keeping a channel of communication between the field and the office. And this starts with your data set, performing an advanced analytical process, and then making it available through the ArcGIS ecosystem. That end-to-end workflow, is really only capable with inside of the ArcGIS platform. Please. Now. Just real quick before I pass this back over to Jeff for a moment to discuss the return on investment from some of these projects. What's been implicit this entire time, but I want to be very explicit about, is this end-to-end geospatial AI lifecycle. You've got data access / management, right? You have access to your imagery through image server or raster analytics server. You have data preparation or data engineering, where you manipulate the data, make it clean, get it ready to be consumed by a model. You then label the data to create a training data set and then train a model on that training data set. Once you've done that training process, you can deploy the models to production inside of the ArcGIS platform, consume the models inside of a dashboard, and then run that inference at scale as a part of this entire workflow development process so that you ensure that the work that your data scientists are doing actually comes to fruition. You actually make a decision based on that analytical process, and you get that return on investment based on your assets back in the field. Wrap up by describing these buckets one more time in terms of the ArcGIS platform. So data engineering, this is a process that you can do in Python, in Pro, or at the server level. Visualization, exploration, and sharing and collaboration. This is the endpoint for that analytical process where you can share your dashboard, share your charts, share your insights workbooks or your ArcGIS notebooks so that people can continue with the work that you've done and make it actionable for your business. Spatial analysis, machine learning, and AI. Machine learning is a particular type of analysis that may or may not use spatial data. For us, geospatial AI is the fusion of that spatial analysis process with the power of machine learning capabilities. And then big data and modeling, again, are those underlying cross-cutting sections where you've got data that's incredibly huge, or you've got a task that needs to be modeled and automated using scripts, and it has to exist inside of a platform that can handle all of these different buckets and processes so that you can actually get that return on investment. And to talk a little bit more about ROI, I'm going to go ahead and pass it back to Jeff.
Cool. Thanks, Sam. So Sam showed you kind of 3 examples, and I kind of just want to go back through them really quickly. If we look at the roads example, the field roads, right? If I was trying to calculate ROI for that particular process, I would think about what time has been spent or lost with field crews not be able to find the most efficient way to get to those locations, right? So how much savings can I get by gaining some efficiencies in the field? Also, by using the machine learning and AI, how many man hours am I saving building those roads, connecting those dots, right? So I've got a bottom line, both in the field and on the back office. And for the investment, really, I'm looking at maybe Tracker and some of my existing desktop tools. So pretty quickly there, you can see that there's a pretty nice ROI on just that one workflow that will help automate the field crews and help enable them to be able to navigate around their operations more efficiently. Looking at the wellhead detection and well activity detection workflow, if we think of that as more of a top line ROI, if we understand changes in the field sooner than anybody else, where pipelines are needed and where pipelines might be underutilized based on these gathering field activities, and get that information over to our business development folks before our competition has it, there's clearly a gain in top line revenue there that could be had through that workflow. And in the final example of the encroachment, there's probably 2 ROI inputs there. One is, what is the time savings of having somebody sit there and scroll through imagery looking for new structures that pop up along the right of way? And the other one is, what's the risk reduction, right? If we can identify those encroachments faster than we could in our manual approach, and potentially, one of those structures that maybe out of 1,000 we can avoid some type of incidents or conflict with the pipeline, what's the cost to the company for that risk reduction, right? Those would be the 2 inputs to that ROI. And again, the investment there is basically the imagery and your existing desktop tools that you have now. So those are ROIs that we have for those 3 examples. And with that, we'll open it up to questions.
Thank you, Jeff. Appreciate it. Thanks, Sam. Nice job, nice demos. We do have some questions. Let me just toss a few out to you. One of the questions is, interesting, how do we get started? One of you want to take that one?
Absolutely. So if you want to get started, we have a couple of places that we'd recommend you go. The first one is the Esri Academy. We have a spatial data science, which is a massive open online course that'll essentially guide you through those buckets that I talked about. It'll teach you about data engineering and manipulation, performing analytical tasks, including machine learning and deep learning. It'll take you through data visualization and sharing, and then kind of how to build out those applications on top of it. So it really does cover the entire end-to-end life cycle. The other way you can get started is by contacting us. We often do a lot of workshops, either virtual or on site, whenever that's appropriate. That our data scientists will actually come on board, help you get up and running, make it to where you not merely get contact with the concepts, you actually understand what's happening underneath the hood, so that you can maintain and run it yourself. The other way you can get started is if you want kind of us to build something out for you. So that's a service that Esri provides. If you want, if you've got a use case in mind, right? If we've sparked your inspiration about something that your business can get value off of, come and talk to us, and we can actually perform that model development for you, and then make it to where you can just get started at the deployment level as opposed to everything before that. Yeah.
And this is something that Sam and I are actively looking for, right? So, obviously when we think of big data and things like that, we think of ILI and CIS data and those type of workflows as well. So those are additional workflows that we're already working on, but the best ideas out there are coming from you guys. So please share with us, even if it seems off the wall. We're looking for those types of things and figuring out how we can utilize this technology to answer some of these more complicated questions.
Yeah, thank you both. I'll take the next question. There was a question about whether we will be sharing today's presentation. Answer to that is yes, we'll share what we can with you afterwards. There is a question also, is the PODS data model supported?
Yeah, so the way that we are really supporting the pipeline industry and PODS being sort of part of that infrastructure is, and I spoke about this in the upfront, as most companies are sort of modernizing their GIS and making that data in that PODS more spatialized, right? That's the key to getting it into the GeoAI process. So most organizations have a spatial representation of the data in PODS, and that's where we'd start as an input to the GeoAI process to bring that data into the models, into the Python notebooks, and start doing analytics there.
Okay. Next question takes us Subsea. Do you have any examples of successfully applying these techniques to seabed data? So the results of the multi-beam surveys that produce extensive point sets, we deal only with submarine pipelines, but have still large data sets.
Yeah, I have seen some examples, and they really fall into the sort of LiDAR category, right? So where we have some type of wide beam imagery data set that we're bringing back into the platform, and then doing some training data sets to look for things along the ocean floor that might be in conflict with those pipelines, and then identifying those either from a video feed or from a sort of wide beam kind of LiDAR like feed, and then pushing them through the model. So that does fall into the, I would call, sort of raster and video bucket, and then hooking up the machine learning algorithm to those data sets to gain some insight to those data sets coming in. Sam, any more along that?
No, I think you pretty much covered it. If you have data for the subsea, we can probably evaluate and see what kind of use case it is you're looking for. The short answer to most of those questions is that anything is possible. So let's have a chat about what it is that you want to get done on the seafloor, and we can make that the spotlight example, so to speak.
Okay. Next question, is the AI training, learning one task at a time, or can you nest or build the learning tasks?
Yeah, so it depends on which tasks you're trying to get it to do. So, for example, if you want to train it to detect 3 different types of things in imagery, that's easy. That's something that models kind of naturally do. But training something to, let's say, detect, an object in imagery and read a book and and take the text from a book and speak it out in kind of natural language. Doing those two tasks inside of a single model wouldn't make sense at an architectural level. So depending on the task, yeah, you can nest a number of tasks inside of a single model, but at some point it becomes logical to separate them into separate models if that's necessary. Yeah.
Okay. Another question just came in, which is back to the data model theme. It's one we've gotten from time to time, and I know Jeff Allen is ready for. What's better, UPDM or pods?
Yes, my famous UPDM or pods question. So I would say from an Esri perspective, really either or. What we really are after is that data to be in an enterprise spatial database, right? So most of the customers that we're talking to these days want to migrate away from complex relational models into more seamless enterprise geodatabase, right? Whether that geodatabase structure is pods or whether that structure is UPDM is really dependent on the needs of each of those individual organizations. And from a software perspective, from Esri, we often say that our software is sort of data model agnostic. So everything that Sam and I talked about today would really work as long as it was spatialized. It would be sort of agnostic to which model it was coming from. Now, obviously, there are some nuances there. For example, if you wanted to do some networking analysis, then obviously we'd have to have a network model within those models, right? So today, UPDM has the ability to integrate a network model through the utility network, and that's something we're working on for pods. So I have a new initiative within pods to add utility network support to the pods model, which would give us that connectivity, which allow us to feed that connectivity into these type of analytic processes. So there's no simple answer, and I often do a kind of a whiteboard session with our customers to walk them through their different use cases and different needs to come up with their ultimate choice between the two. But those are a couple of kind of key indicators for me when trying to make that type of decision.
Well done. Thank you, Jeff. You actually also answered one of the follow-on questions, but there is one more. How about pods and APR?
So really pods has now, at least at pod 7, has the embedded support for the ArcGIS pipeline referencing. So when we designed pod 7, and I was part of that team, we took the core information model for ArcGIS pipeline referencing and added it to the core model. That doesn't mean that you couldn't add those same tables to prior versions of pods and make them spatial. And I have seen organizations successfully do that as well. But the idea there is that ArcGIS pipeline referencing, again, is sort of data model agnostic. As long as it has its core fields and core tables for linear referencing, it can be enabled in any versions of pods, but it becomes native at pod 7 in the newer releases.
Super. Thank you. One question just came in. Does Esri have a facility data model managing buildings, assets, asset retirement, etc.?
Yeah, so we've been working on a couple of things there. One is we've been leveraging that same networking capability, the utility network, to go inside the building. And when we do that, we often leverage things like LiDAR data sets, as-built drawings from CAD, Revit files as our basis for building out those buildings, facilities inside the buildings. We also have ArcGIS Indoors, right, which is a fusion of bringing our GIS technology inside of a space. So Utility Network has the modeling capabilities for the pipes. ArcGIS Indoors has the modeling capabilities for buildings and building infrastructure. And the fusion of those two technologies would be applicable to that particular use case.
Many thanks, Jeff. Is there a pool of Geo AI training script that can be used, or will users need to program all unique scripts all the time?
Yeah, good question. So the ArcGIS API for Python has a bunch of built-in models into it. You'll have to train those models, but you don't have to write the scripts that make the model work. For example, if you're building something that's detecting well pads, a good model for that we used in this particular example is a single shot detector. And single shot detector is just a model that already exists in the API for Python. You just import it and use that as your model architecture. So you'll find that with most deep learning libraries or machine learning libraries that there's a lot of model architectures that are already built into it so that you don't have to build it from scratch. And then it just depends on what you want to do, which architecture is best, and we can help you figure that out.
Thank you. Is it possible to automate HCA analysis using machine learning?
So the answer to that is probably yes, right? So the structure location, let's take the whole workflow, right? So as Sam showed, we can take imagery and automatically detect new structures along the right-of-way within the 660-foot buffer. Then we would need to add and most likely enhance that data with some field input, right? So the model would detect a building. We would then automatically send out a notification to the field staff to review that new structure, maybe confirm that it's actually inhabitable. It's not just a barn that was being built along the right-of-way that doesn't have any people in it. If it was inhabitable, it would then become a new DOT structure in the data model. That new DOT structure could then be automatically identified as part of a new feature along the right-of-way. And then a class or an HCA tool could then be triggered to recalculate the class based on that new structure within that 660-foot buffer. So it's a couple of different workflows, but the idea here is to string those out into a much larger model that maybe cover a process over time and be able to hook that all together. And again, if we look at that process end to end, there's quite a bit of manual bottom line savings that we could see by trying to automating and hooking a lot of these processes together.
Super. Thank you very much, and thanks to all of you who asked questions. I think we've answered all of the general questions. I do see some which are specific to you or your company, and we'll get back to those individual questions separately after the seminar. So thank you. We appreciate everybody's participation. Hopefully you have found this to be meaningful and insightful. Thank you again for joining us today. Have a great day.